When determining the arc flash duration associated with a utility primary of a current protective device or OCPD of a transformer that has a low percent impedance, the duration is determined by the time it takes for the fault current to build up and the secondary of a current protective devices to clear the fault. The formula for arc flash time, T, in seconds, is equal to the quantity xt plus xr divided by the quantity 2 times pi times f times I. In this formula, xt is the transformer reactance in ohms. Xr is the feeder reactance in ohms. F is the system frequency in hertz, typically 60 Hz. I is the maximum fault current in amps. Now let's consider the melting time for a secondary conductor. If an arc fault occurs on the line side of an overcurrent protective device in a main lug-only panel board, the primary of a current protective device will not trip immediately. Instead, the fault current will continue to flow through the secondary conductor until the conductor melts and interrupts the circuit. The melting time for a conductor depends on the conductor size, the material of the conductor, and the current flowing through it. Here are some approximate melting times for copper and aluminum service conductors. For a 1/0 conductor, the copper melting time is approximately 1.0 second, while the aluminum melting time is approximately 1.5 seconds. For a 2/0 conductor, the copper melting time is about 1.5 seconds, and the aluminum melting time is about 2.0 seconds. For a 3/0 conductor, the copper melting time is around 2.0 seconds, and the aluminum melting time is approximately 2.5 seconds. For a 4/0 conductor, the copper melting time is approximately 3.0 seconds, and the aluminum melting time is approximately 3.5 seconds. For a 250 kcmil conductor, the copper melting time is about 4.0 seconds, and the aluminum melting time is about 4.5 seconds. Finally, for a 350 kcmil conductor, the copper melting time is around 5.0 seconds, and the aluminum melting time is about 5.5 seconds. For parallel service conductors, the melting time is reduced because the current is shared between the conductors. The approximate melting time for parallel conductors can be calculated using this formula T equals T single divided by N. In this formula, T is the melting time for the parallel conductors, T single is the melting time for a single conductor, and N is the number of parallel conductors. Here is an example. Consider a transformer with a primary of a current protective device of 1500 amps and a percent impedance of 5%. The utility feeder has a reactance of 0.5 ohms. If a fault occurs on the line side of an overcurrent protective device in a main lug-only panel board, and the secondary conductor is a 2/0 copper cable, what is the arc flash time? Step 1. Calculate the transformer reactance. Xt equals 0.5 times 1500, which equals 75 ohms. Step 2. Calculate the feeder reactance. Xr equals 0.5 ohms. Step 3. Calculate the arc flash time using the formula T equals the quantity xt plus xr divided by the quantity 2 times pi times 60 times 1500. T equals the quantity 75 plus 0.5 divided by the quantity 2 times pi times 60 times 1500, which equals 0.3 seconds. Step 4. Determine the conductor melting time. From the table provided earlier, the melting time for a 2/0 copper cable is approximately 1.5 seconds. Step 5. Calculate the total arc flash time. The total arc flash time is the longer of the arc flash time and the conductor melting time. Total arc flash time equals the maximum of 0.3 seconds and 1.5 seconds, which equals 1.5 seconds. Therefore, the arc flash time in this case would be approximately 1.5 seconds.